Welcome back to CAD/CAM tutorial. Today we are going to design a simple hydraulic cylinder in Solidworks. Here we will design multiple number of parts and we will assemble at the end, and we will give this small animation. I hope you like it. So let's see how to do in Solidworks. Here we did many number of parts, all inside parts, piston, then shaft, barrel, both the end caps. So let's see how we will do it. Now here we will make our first part of hydraulic cylinder. This is called barrel, or you can say hydraulic tube. So let's choose here front plane, sketch, and select circle, and here draw two circles, smart dimension, and keep outer one 114.3 millimeter. This is the rough dimension. Then inside 88.9 millimeter. See, okay, and extrude it, and here we will extrude up to 362.5 millimeter. Choose this isometric view. Okay, that's it. Now here we want to make some cutouts inside, so select this face, sketch, circle. Just take a little position, and so that you will easily keep outer diameter 101.6 millimeter. Okay, and select the inner circle and convert entities. Now it is converted, so go to feature, select extruded cut. Now this circle we need to cut it only 10 millimeter inside. You can see the preview here. Okay, that's it. Now in upper face we apply some solid color, yellow, because it looks better. Then edit appearance and make little orange so it looks real. That's look fine. And just note down this one 255 204, because our all geometry based on this color. Any color you can choose, it's up to you. Okay, now this is the this cylinder is ready. If you like to add some inside some material, so just simply select the inside bodies and go to appearance. Here you will find metal, let's say polished steel, anything you can apply, or you have one more option, chrome, polished chrome. Chrome is looks better. Now let's save our first part. Go to desktop and find your destination, hydraulic cylinder. This is our part number 1. So barrel, save. Let's see what other parts are here. Here the next part is piston rod. So let's start. Choose here front plane, sketch, and choose circle. Let's draw a circle, and here we will keep the shaft diameter or rod diameter 57.15 millimeter. Now extrude it. Extrude up to 530 millimeter long. Okay. Now let's start to cut from this face, sketch, circle. Let's make diameter 37.8 millimeter. Select here extruded cut. We want to cut up to 38 millimeter, but select here flip side to cut. means outside we need to cut, not inside. Okay, now see, the same thing we will do it here. Sketch circle, let's draw a little bigger circle, and let's keep the diameter 41.28 millimeter. Again select extruded cut, keep the length 40 millimeter, and select flip side to cut. Outside we need to cut. Okay, that's it. Again choose the same sketch, this surface circle. You can take the normal position also, it's not big deal. Diameter 49 millimeter, select extruded cut. Make length 55 millimeter and select flip side to cut. Outside we need to cut it. You can see here arrow direction. Okay, that's it. Now this is the our shaft. Let's extrude here some. Select this face, sketch. Keep the diameter 10 millimeter and extrude up to 5 millimeter only. This is for locking purpose. Here one end cap going to lock here this face. Okay, if you like to add some chamfer or fillet like this, let's try. Okay, now let's assign some material. Go to metal, choose chrome finish, that looks nice. Even if we apply satin finish, that also looks better, satin finish, but it looks a little dark. If you will go to aluminium, and here also satin finish aluminium, this also it's look better. Steel, let's try this polished steel. Okay, let's do this polished steel, it's look better. Save, and here save part number 2, piston rod. Now next let's here the third part is hydraulic cylinder piston. So let's start. Choose here front plane, sketch, draw here 2 circles, and let's make outer diameter 88.4 millimeter, because our bore is 88.4 millimeter. Even you can make little less, 88.35 millimeter. It's a small tolerance. This one 41.25, because our cylinder is 41.28 millimeter. So here also a small tolerance. Now extrude. Choose reverse direction. Any direction you can make it, 55 millimeter. Okay. Now let's select right plane, sketch, draw first center line. Make sure it's horizontal. Select line, start from here, draw some corner rectangle. Exit. Now select these 2 rectangles, these 2 lines collinear, and this line also make collinear. That's it. Now let's define the distance from outer edge. 5 millimeter, 3 millimeter, 15 millimeter, 6.5 millimeter and keep the height 8 millimeter. Now let's define the gap. 4.225 millimeter, 5 millimeter. Okay. Now here create one relation. Select these two lines equal. That's it. Now select these two vertical lines, make relation equal. Now see, geometry is fully defined. Just go to feature, revolve cut. Here select the center line as a axis of rotation or axis of revolution. Okay, that's it. Let's try some small chamfer. Okay, select back surface, sketch, and draw a circle. .10 millimeter and cut, and make the depth only 15 millimeter. Okay, that's it. Make chamfer 1 millimeter and select this corner. Select this face, sketch normal, and here we will make some or do one thing, circle, and let's draw a circle up to mid for construction. Okay, let's choose it how much, 66 millimeter circle, and here draw two circles, exit. Now select here both the circles and keep equal relation. Okay, now let's define this 8 millimeter. Now select extruded cut, and we want to make a hole depth, keep 9 millimeter. Okay, that's it. Now this is a kind of piston, and this groove for the sealing, hydraulic sealings, satin finish stainless steel. Save. Part number 3, piston. Now here one sleeve also there for piston. So here we will do some modification. We need to make increase this cutout, edit sketch. Just do one thing, increase this diameter 49, exit. That's it. Now that's fine. Save. This is the part number 4, piston cap. So front plane sketch, and here draw two circles. Outer one keep 60 millimeter and inner diameter make 49 millimeter, and extrude up to 55 millimeter. 40 millimeter. Okay, choose here chamfer, keep 1 millimeter, and here select 30 degree. Select this corner, make 5 millimeter. Okay, that's it. Actually we want to little increase, make 20 degree, 10 degree. Okay, keep 20 is better. 7 millimeter, 20 degree. Okay, that's fine. Fill it. 1 millimeter. Select both the edges. Okay. Now let's save this satin finish stainless steel. This is piston cap. Let's save part number 4, piston cap. Let's see other parts. Here let's make the next part, end cap of cylinder, hydraulic cylinder. So choose your front plane. And draw a circle, and let's keep the diameter 127 millimeter and extrude. Extrude up to 43.3 millimeter. Okay. Now select this face, sketch, draw here a circle, and let's keep 88.9 millimeter and extrude 8.7 millimeter. Okay. Select this face, sketch, normal. Now here we want to make a bore. (38.2 millimeter) and select extruded cut. Make the depth 38 millimeter inside. Okay. See, that's it. Chamfer. Keep 1 millimeter, 45 degree. 2 millimeter is better. Okay. Now choose your fillet, 2 millimeter, and select this face. Okay. Now let's select these two faces and define some color. (255-2040 RGB). Okay. This back side also the same color. And this fillet. Okay. Now let's create one plane. Choose top plane, and draw one plane at the height of 61.6 millimeter with the reference of top plane. Now select this plane, sketch, circle. We want to draw a circle in mid line. Let's draw a center line. Select this circle, exit. Now select this circle, make relation horizontal. That's fine. Okay. Cancel this distance. (38 millimeter). Okay. Now create one relation. Select this center point of circle and origin point and make vertical relation. Now you can see it's fully defined. Select extruded cut, and we will make a very small depth, 1.6 millimeter. That's it, not more than. Here select blind, 1.6 millimeter. Okay. Or edit, this not perfect. Select here center rectangle, draw a big rectangle, 55 millimeter, and okay, exit. Now edit this feature, and here select contour, select this all faces. See, here we selected circle and this rectangle also, and go to direction 2. Direction 2 make more. See, direction 1 1.6 millimeter. Okay, see, that's it. Now again choose this same sketch, extruded cut. Select here, and here select clear this circle only, and make the depth 1.6 millimeter more. .2 millimeter. Okay, now that's it. Now hide this plane, select this plane, sketch normal, and at the center point create one circle. .8 millimeter. Select extruded cut and make the depth 23 millimeter long. Okay, now select the inside face, sketch, undo. Okay, again select inside face, sketch, circle, and draw one circle in midpoint. .15 millimeter, and it should be cut. You can see it should be cut up to here. Okay, now see, this is the depth. Now here our fittings going to fit. Choose right plane, sketch, normal, circle. Now let's make the distance 43.3 by 2 millimeter. .11 millimeter, and select extruded cut. Here choose reverse direction, and condition keep through all. We want to cut a throughout hole. See, select this face, sketch, for construction geometry, and draw one circle here. Now let's define this. 64 millimeter, 5 millimeter. Now select extruded cut. Okay, this should be, this going to be met here. Okay, that's it. Chamfer, select only this edge, make 1 millimeter, and select this edge also. Okay, chamfer, this inside edge. Okay, so this is the our simple end cap. Now select this all faces, and apply material. Go to appearance, steel, stainless steel satin finish. That's it. Let's save this. End cap. Here the next part is barrel cap. So let's start. Okay, let's choose front plane, center line. Draw a vertical and a horizontal center line. Connect, exit. Now let's define it. 40 millimeter. 48.25 millimeter. Select this point. 57.15 millimeter. Now select this line. 72.5 millimeter. This distance 23 millimeter. Okay. Now choose here revolver boss base. Select this line as a axis. Okay. That's it. Fillet 5 millimeter. Select this end. Make it 10. Okay. Now select this face, sketch normal. Now here sketch two circles. Let's keep the diameter 101.6 millimeter outer one, and let's keep inner one 88.9 millimeter. Now extrude 10 millimeter. Select these three faces, material 255-2040 RGB. That's it. Select this face, sketch, and here we want to create some bolt holes. Make one construction circle with construction geometry 125 meter diameter, and create here one circle, and let's keep the diameter 10.7 millimeter. Now select extruded cut 19.74 millimeter. Okay. Define some chamfer. Okay. Now let's make multiple number of holes. So choose here circular pattern. Chamfer already selected. Select extruded cut. Select any circular face. We want 12 number of holes, equal spacing 360 degree. Steel, let's try polished steel. That's it. So now this is the end cap. Sorry, this is barrel cap actually, not end cap, barrel cap. Let's save it. Barrel cap. Now select. Now let's make some other parts. Here the next part is front cap of hydraulic cylinder. So let's choose front plane sketch and select here circle and draw a circle with 145 millimeter diameter and extrude 42 millimeter. That's it. Now select this face sketch circle. Let's draw a circle into this face. Make the diameter 96.4 millimeter and extrude up to 33 millimeter. Okay. Now let's say right plane sketch. Select your line. Connect it and draw one center line. Click on the center line and here select construction geometry. Now let's define this. Distance from here to here 95 by 2 millimeter. It's 47.2. The bottom one select 57.2 by 2. Okay. Now let's choose this length. 42 millimeter. Select this point from this center line. 83 by 2 millimeter. That's it. Revolve boss base. See this center line selected. Okay. Select this face sketch and we want to create a bore here. (57.2 millimeter). Select extruded cut and here choose end condition through all. Okay. This face sketch circle. Let's draw a circle and keep it 70 millimeter diameter 70 millimeter and select extruded cut and make the depth small depth 8 millimeter. That's it. Now let's see. Okay, right plane sketch. First draw a center line. Corner rectangle. Draw a rectangle. 6 millimeter. 10 millimeter. 12.5 millimeter. Select revolve cut. Select this line as a axis. Okay. It's we created a kind of groove. This is for, you can say, oil ring or oil seals. Fill it. Choose here 5 millimeter. Okay. Now select this face sketch normal and here we want to create the bolt holes. Select this this circle for construction purpose and draw one circle here. Now let's define this circle. Keep diameter 125 millimeter and the circle hole diameter 10.7 millimeter. Select here extruded cut. Keep end condition through all. See, now let's make multiple number of holes. Circular pattern, select this hole, and here perimeter, select this circular face. We need 12 number of holes, equal spacing. Okay, that's it. Chamfer 2 millimeter and select this corner. Now here edit some color. Zero. This is the our required color. Select this face up to this face. That's it. Okay. Now choose top plane and create one plane above the 61.6 millimeter to the top. But this is it seems the hole is going to cut. Even 68 also not sufficient for up to that level. Okay, so let's create here .68. If we will go for 68, it's actually it's too big. Let's keep 70. Okay. Now we will close this hole. No need, just select this plane, sketch, center rectangle. .51 millimeter. Okay. Now select the origin point and center of the rectangle, collinear. That's it. It's important. Extruded cut. Blind, make the depth 1.6 millimeter and direction 2. Take it upward direction. Okay. Now hide this plane. See, select this face, sketch. Now here draw two circles. Oh, okay, one is enough. 38 millimeter and select extruded cut and make the depth 1.6 millimeter. Okay. Select this face, sketch, edit, select this face, sketch, select this circle, convert entity, extruded boss, reverse direction, length I think we know 42. Okay, that's it. We close this holes actually. edit. Okay, sketch circle, make the diameter 24.8 millimeter and select extruded cut 23 millimeter. Okay, this is extra portion we created, so select this face, sketch circle, select here extruded cut, upward direction. Okay, that's it. Now select inside hole, sketch circle, and draw a circle in mid and keep the diameter 15 millimeter, and select extruded cut and make the depth up to, okay, it should be comes to this bow. Okay, that's it. Select this face, sketch circle, and just draw the circle above the 6 millimeter. Okay, now select both the points horizontal and distance 39, let's say. Extruded cut. Now choose here up to surface, up to this surface inside. Okay, so see, these holes are going to connect 1 millimeter. Okay, we need to create one more hole for greasing. Sketch top plane. Here you can see 2D drawings. So here we will create our hole. Four millimeter, 5 millimeter. Okay, now select this circle center and this origin point vertical. Now it's fully defined. Select extruded cut. Here choose through all reverse direction. See, okay, now that's it. We will edit this one. Edit sketch, make offset 50 millimeter. We want to create here hole, so 40. That's perfect. It's going to create a hole here. Okay, see, so this is the our piston. Now I'll select this all faces, go to appearance, satin finish stainless steel. let's save. This is the part number 7, front cap. Okay, I let's see what other parts are balanced here to produce. Now here let's make front clavis. Choose front plane, sketch, and here draw two circles. Outer one keep 146 millimeter and inner one 80.9 millimeter. Now extrude. .8 millimeter. Okay, choose fillet 3 millimeter. Okay, now select top plane and create one plane just above the top plane and keep 75 millimeter above the plane. Okay, select this plane 1, sketch, and draw here a circle. Connect with this circle, exit. Keep dimension 37 millimeter, and we need to create distance. Let's define this one. .8 by 2 millimeter. Okay. Select extruded boss, reverse direction, keep up to surface. Select this surface. You can see here. Okay. Now hide this plane. Chamfer. Select this face. Keep 1 millimeter. And select this inside face. Okay. Now select this face, sketch, circle. Find out center point and create a 22 diameter circle. Extruded cut. Make the depth 14 millimeter. Now again choose inside face, sketch, circle, and let's find out the center point. Take the position. Okay. .9 millimeter extruded cut. Take it down. See. Okay. Now select top plane. We need to create one more plane, so choose plane 60, make it 68 millimeter. Select flip mat because we need to create from bottom side. Okay, now select here plane 2, sketch, center rectangle. Find out the center and draw a big rectangle. See here, and select extruded cut, bottom direction. Okay, see, now hide this plane also. Select this face, sketch, normal. Now here our piston or piston rod may be going to fix, so make a hole. Let's define 10 millimeter. And let's make distance 50.8 by 2 millimeter, 25.4 millimeter. Select the center point of circle and origin vertical. Select extruded cut and keep the depth blind 5 millimeter only. Okay, that's it. Select this face, (204) and this one 0. Select this face, this face. Okay. Select the full body and polish the steel. Chamfer. Select inside face. Clear. Select edges. Okay. Now this is the front clavis. We need to create one more geometry here, so select here right plane, create plane, and keep flip side. Okay, 68 millimeter. Okay, now select this plane, third sketch circle. Let's draw the circle, 36 millimeter and the diameter 32 millimeter, and let's make the distance from outer edge or choose origin point 25.4 millimeter. Select here extruded boss and choose up to surface. Select up to this surface. Clear. Up to next. Try. That's better. Up to next option. Okay. Now hide this body. Choose here fillet 1 millimeter. It's okay. Select this two parts. Appearance yellow, and here 255 2040 RGB. Okay, so that's it. This is the our front clavis. This is for reference purpose actually. Let's save part number 8, front clavis. Let's see the next one, right, rear clavis. Now here the last part is rear clavis, so choose front plane, sketch circle. Let's draw a circle first. That's it. Now choose here line, exit. Now connect this line with center point, exit. Select this line, make relation vertical. Let's define this, 146 millimeter, 100 millimeter, and let's 75 millimeter distance. Okay, now choose here line and connect with this. The same thing, exit. Now select circle and line and keep relation tangent here also tangent. Okay, now select extruded boss. Select this face and this circle and extrude up to 50.8 millimeter. Choose fillet. 5 millimeter, select both the direction. Okay, that's it. Now edit our previous sketch. Edit sketch, circle, add one circle here, just 80.9 millimeter. Exit. That's it. See, the hole is created. Now let's create a plane. Right plane, plane, 68 millimeter, choose flip direction. Okay, select plane 1, sketch, draw here a circle. Let's make the distance 33 millimeter, diameter 36 millimeter, and distance from 25.4 millimeter. Now select extruded boss. Here choose only up to next. That's it. Hide the plane. Choose here fillet 1 millimeter. Okay. Now let's try to mirror. Right plane, mirror, and select this body, fillet. You can see the preview here. Okay, that's it. Edit and delete the fillet, or let's choose fillet geometry pattern. Okay, that's fine. Select this face, sketch, normal, choose here circle, and here we want to create some hole. (21 millimeter) and extruded cut. Make the depth 14 millimeter. Again choose inside surface, sketch, circle, and keep the diameter 9 millimeter. Select extruded cut. Extrude. That's it. It should be come out from here. Okay. Now this is the our simple rear clavis. (204). Now let's select all these parts. Here that's we selected all the parts. Let's check, cross check again. Okay. Now select the full body and define the color polished steel. Let's save this part number 9, rear clavis. Now here we will see the assembly of hydraulic cylinder, how to do the assembly in Solidworks. Let's choose here new assembly. Okay, now this is the Solidworks assembly window. Let's browse our first part. Always remember, whatever first part you are going to choose, it will be fixed by default. It will be fixed, you can change it later on. So we will choose this barrel because there is no movement in barrel, so we will keep barrel as a plane. Now the second one, choose piston rod and piston, and choose piston cap also. Piston rod, piston, piston cap. Rotate all 90 degree. This one also rotate 90 degree. This one okay, that's perfect position. Choose here matte. Select inside face and this. Make relation concentric. Okay. Select this face and this face. Make relation coincident. Okay. Select this face and this rod. Concentric relation. Drag it. Piston body and this coincident. Okay, now this is fixed here. Let's browse our other parts. Select here barrel cap and front cap. This is barrel cap and this is front cap. Matte. Select the inside face of barrel and cap. Inside face, choose here circular concentric relation. Okay, select this face and choose barrel outer face, coincident relation. Okay, now let's revolve this. Okay, now choose relation. Select outer circular face and this circular face. Make concentric relation. That's it. Now select this one hole and this hole. Concentric relation. Okay. Select this outer face and this face. Coincident relation. Okay. We will try to keep this one upward direction. So edit piston, this body color I don't two 204 255 RGB. Yes, that's fine. Now choose barrel. Select right plane of barrel. Come down and front cap. Press Control key and right plane. Select right plane of both the barrel and front cap met. See, okay, coincident relation. The same we will do it for this cap also. I think no need, because this cap will not rotate because this is fixed with this. Okay, again choose met. Select this rod and this barrel, concentric relation. Okay, now the barrel is inside, so let's keep it inside. Front and rear clavis. Front and rear. Now rotate this one. Make it this one downward direction. Okay. Choose met. Select this circular face and this hole. Make concentric relation. Okay. Select this face and this face. Coincident relation. Now first choose piston rod and select the plane. Right plane, no. Okay, let's choose front plane of top plane of rod and rear clavis. Oh, sorry, not rear clavis, front clavis. Press Control key, front plane. So select met. Make coincident. I think it's cancel it and we will try it again. Top plane. Okay, choose the top plane of this rod, met, and this plane. Make choose here parallel relation. Okay, okay, that's fine also. But the rod is rotating, so we have to do one thing. We have to select these two relations. Rod, top plane of rod and front cap. Press Control key, right plane. See, right plane of front cap and piston rod top plane met. See, it's going to met in one line. Coincident relation. Okay, okay, that's fine. Now it will move. See, it will move in a line. That's a nice relation. Now hide all the now let's browse what else balance. Here you can change the size, large icon, so it is easily visible for you. End cap only balance, I think. Open. Now choose met. Select this cylinder and this, make relation concentric. Okay. Select this face, end face, and this face. Coincident relation. Okay. Now choose barrel. Right plane of barrel comes down, end cap. Press Control key, right plane. Right plane, both the right plane choose. Barrel and end cap right plane met. see here, coincident relation. Okay, okay. Now just hide this all relation. Okay, that's fine. So this is the, what else balance? Let's rotate the end cap. Okay, we will fix it like this way. Okay, choose this face, met, and this face. Make coincident relation. Okay, let's try this part. This is the part number. Okay, rear clavis. Choose front plane of rear clavis. I think no, we need to define it with other plane. Okay, we will define it with right plane of clavis, and go to top barrel. Press control key, top plane of barrel. See, press coincident relation. Okay, now here select this face and this face. See, it's going to fix coincident. That's it. Our hydraulic cylinder is ready. See, now here we can actually we will do one thing. Just check limitations up to here. Okay, choose met, and here go to advanced met and select here distance. Select this face and select this face. Okay, keep gap 1 millimeter, the gap between these two, and here make 300, minimum 1 millimeter. Okay, okay. Now we fix maximum. See, this is the maximum. It will not come out more. Minimum, maximum, minimum. See, maximum, minimum, maximum, minimum. So this is the our main. Let's save assembly first. We will save it hydraulic cylinder assembly. Now here we will fix the nut and bolts. So just go to design library. You can see here, select here tools. Once you go to toolbox, go to NC metric and bolts and hexagonal bolt. Choose hexagonal bolt, and here you will find, we will use some hexagonal flange screw. Okay, that's fine. Now do one thing, just drag it to this hole, then come to this surface. See, keep M10 because length make it 50 millimeter. Thread length, okay, 26, something like that. Schematic. Okay. Now again go to this hole and this surface. That's it. Again go to this hole, this surface. In the same way we have to do it for all the holes. First go to hole, then surface. Do not click before, just show the preview. Okay, now here we fixed all the bolts, screws, not actually bolt, it is actually screw. Again go to design library and go to SKF bearing, ball bearing, select angular ball bearing, drag it up to this circle. Here choose we found one number 7308. BE, that's fine. Ball 10 numbers, okay. Choose here detailed, add cage, okay. Drag one more, let's drag this one more, exit. Choose mat, select this face and bearing face, coincident relation, inside, and this concentric relation. Select this side and this face, coincident relation, okay. Now comes out here a small bearing, concentric relation, select outer face and this outer face, coincident relation, inside face and bearing, concentric relation, outer face and the outer face of bearing, okay. Okay, so that's it. Let's save it. Now here let's make some animation. Choose motion study. You can select from here motion manager, just up these motion analysis, go to option and keep frame 50 frame per second. I prefer 50 frame, but it's up to you what you like. Give up to 6 seconds and here choose temporary axis. Select here motor and select this arrow, this temporary axis. Here select linear, motor or actuator. Now comes down and here we will define the speed. So let's say we will make in little faster, 70 millimeter per second, okay. Select calculate. Now see, it's going to calculate. Just hide the temporary axis and we will see the result, how it looks like. Just hide and play. See, it looks nice. Play reciprocating and play. See, it's going more outer, so do one thing, edit feature and here define, okay, that's 50 frame, play, because we observe it comes out more than its limit. Okay, that's fine. Now play. That's it. Now just take it down. Now here we will do some we'll create some exploded view. So select here exploded view, select this bearing, take it out, the second bearing. Now here select both the bearings and take it back, select this, again select, take back. Now select this piece, this barrel. Okay, now here also choose the bearing, comes out. This piece also we will try to bring here. Choose piston, take back. Now select all the bolts. Clear. Press shift key and select all the parts. I just zoom it because it's difficult to now all the parts selected, so just take it out. Now the last part, this one take here, then again take it out. Shaft. Okay, now collapse. Now here select animation wizard, exploded view, next. It is duration 19 seconds, that's okay. Start time keep 6 seconds, finish. Again click animation wizard, collapse, next. 19 seconds and here select 19 plus 6, 25 seconds, finish. Now play. That's it. Now the calculation is going on. That's it. Now let's play it. See the piston coming out, and the whole process is going to be repeated here. The dismantling of hydraulic cylinder. I hope you like it. Please subscribe our channel for more video and more projects in Solidworks. Don't forget to share and like our video. If you have any comment, just write down below. I'll try to answer each and every question. And if you have any suggestion, just suggest me. I'll try to make every projects according to the people. Thanks for watching.